to think about how to commercialize generative AI. So based on my research and reading some biased mind in this AI industry, I think essentially there's a two approach for commercializing. One is the model itself, you sell the model. The second one will be the concept called cognitive architecture. We'll go them one by one. So for the model, it's very straightforward. You sell your model and the people pay by consumption. For example, if we do use API to interact the OpenAI models, it will pay depend on how large the question is, how length the question is. And also there can be Meta, Amazon, or Azure, similar idea. They sell the model as itself. As we mentioned before, if you train a Llama 2 from scratch, that is $2 million. And if you want to have a larger model, like 100 billion parameters, that is more expensive. So I think it's not very realistic for our small or medium business. But another angle from this model commercializing is to fine-tune the large language model based on your own data. What fine-tune means is you take the large language model like Llama 2 as your foundation, then you use your own data to customize it for your specific use case. It's like to compress the knowledge of your data and add that to this large language model. Then that fine-tuned model can be your IP, or we are supposed to get a better performance from this fine-tuned model compared to this out-of-the-box models. So that can be a angle for small and medium business to fine-tune their model. And there are also a lot of tutorials and products to easily help you to fine-tune your model. For example, for IBM watsonx, there's a Tune Studio, which you just click and drag your data, then you can fine-tune your model very easily. So that is the first approach, sell the model as itself. The second approach here will be this cognitive architecture. So what this cognitive architecture is, this concept I quoted from this creator, Lindy. So it is basically to describe the orchestration of large language model applications. And for large language model application, you can also understand that is a context-aware reasoning application. And there were two components. One is the context part, how you provided context to the application. The second part will be how the model reasoning. Is there a specific step to do the reasoning? And both of these components make up this cognitive architecture. And if we look into specific examples, the RAG one is a good example for cognitive architecture. The RAG stands for Retrieval Augmented Generation. You may have heard this many times. Just quickly go through this, make sure we're all on the same page. So for RAG, it starts with the user question. And after we have the questions, we'll take this question, go to a knowledge base. Then here we will search the relevant content for this question. That is the retrieval part. After we have this retrieval content, then we'll take that, augment our questions, and also adding some instructions. Then this augmented question will fit into a large language model. Then we'll get our final response. So this is like RAG process. You can see here you have how you fit the context to the application and how you let this application to reasoning how to answer the questions. So that is cognitive architecture. And this RAG is very popular now. And I think it's very like a low-hanging fruit for you to help your customer to start in this generative AI journey. And for IBM example, there is a specific service for each component, and you can build a RAG within 10 minutes. And similar for other vendors like Microsoft or AWS. That is RAG. And for this, the other one is very popular concept is called agent. So the agent one here is, I would say, it's more advanced cognitive architecture. So agent, if we think starting the user question again, so after we have this question from user, the large language model will now thinking, okay, what information I need to answer this question and what tools I have to get that information. So the large language model here will be like smart enough to decide which tool I use and what information, additional information I need to answer the question. That is like the agent come from. And there will be a loop within this agent architecture. So you after you have the question, the large language model, let's pick a tool. The tool can be a web search, can be a generative image, or can be the code interpreter. So it will use that to get additional information. Then the additional information we call observation here will feed back to the large language model. The large language model will thinking, okay, is this enough information for me to answer the question? If not, it will continue go through this loop to get more information until the model think this is good enough for the final response. Then we'll provide the final response. So this will be this agent architecture is more advanced, more complex. And within tech data, we did have 3 demos we developed under this concept of cognitive architecture. These 3 examples, one is this sales GPT. Basically, you have your large language model and you feed the large language model with the tool of web search with the knowledge of your product offering and with the knowledge how to do the sales and also who you will play with. So the sales GPT will basically with that information and to engage with customer to introduce your product. The second good example will be this HR assistant. So the HR assistant is similarly you providing your employee data access to the large language model and you give the HR policy. Then the large language model can play as an AI HR assistant to answer questions on your HR policy. The third one is Scope 3 carbon data estimation. Similar idea. The tool we provided is a calculator. The knowledge we provided is how to categorize different supply chain activity to a specific category. Then you use some formula to do the calculation. So after you give this tool, give the knowledge, and also give some instructions how the model should perform, then that is the agent you created. And you can see here with this concept, cognitive architecture, you can build this application specific for business users. And it doesn't require you to train the model from scratch. You just use the model like an engine of your application and with this different component together to deliver a business case. And I do believe this is a easier or compared to training your model by yourself, this will be an easier and more reasonable area we can focus to deliver the benefit. And for the industry, in very high level, people thinking there will be 50-50 on this two approach. 50% is developing a better, faster model, and 50% is to work on this cognitive architecture for a specific use case.